to this edition of DOKU.TECH. First of all, thank you to Ufos Foundation for inviting me back again, since I was there in the last one in Pristina and Termokis. This time I'm going to be talking about the same topic, but I also brought somebody else to join me, Dren, which is going to be talking about the technical part of a series of RC planes. This is the name of the talk. For all of you who don't know what RC means, it stands for radio control. So 2 years ago, Dren and I, we both have a background in computer engineering, and after work we really wanted to start to do a project of our own. We started by ordering different components online so we could start build something, and that's how a series of useless flying objects came to life. We used different cardboards and all the materials that we could recycle, and we just used these kind of components here to sort of make them fly. Some of them did, some of them just crashed, but still we were trying. But then we decided to expand the project and do something bigger. That's how we came up with the idea to build a bigger RC plane. We named it TARDIS because it was all blue and it couldn't fly through time and space, it just flew. This was our kitchen for 2 weeks. Every time after work we would come back. We used insulating foam and different components that we bought very cheap online. After that, Dren is going to be talking about more. So we just wanted to do something fun and creative, so that's how TARDIS came to life. We took it outside because we wanted to see if it flies, so we used the backyard of our university in Pristina because we didn't want to break any rules, so we were using it for research purposes. We were flying around and we saw that lots of kids were very interested in what we built. So we were trying to explain, so we just found ourselves explaining how physics work, how different components inside work with each other. So we were sort of teaching while we were having fun. But then we wanted to see if we can fly with it more, and then we went to Lake Badovce, which is near Pristina. It's a bigger space close to a lake. We attached a GoPro camera in it, which you can see over there, so we could have more footage to see how we were flying. We're not professional pilots, but we were trying. We were also learning in the process. After this, we wanted to do more, to give more, to give other, to inspire people. So I found out that 2 of my friends who were Peace Corps volunteers in PEA, they designed this technology summer camp. They invited me and Dren to help them out with a workshop. So I'm just going to let this go until it crashes, and then we can continue to the second part. So yeah, well, a funny story about this one is that we flew for more than 20 minutes, and then we kind of lost the plane because the sky was so blue and so was the plane, and we couldn't see it, so it just crashed through in a hill nearby. So we searched for it for about half an hour until we found it. So this is the current state of the TARDIS right now. We did lots of improvements. We expanded the wingspan, but we also used it to get the components out so we could use it in other planes that we build in the future. So far, we have more than 20 airplanes, quadcopters, and gliders that we flew and crashed and reused again. This is the workshop in PEA that I mentioned. So they are all kids in elementary school from 12 to 15 years old. They spent a whole day with us, and at the end of the day, they built one airplane and they learned how to fly it outside. So that's what happened throughout the day. We were just having fun designing it. They were building, like they were drawing pictures around, they were having fun with cutting all the objects that needed to go inside. And at the end of the day, we just had fun with kids who also learned a lot in just one day. After this one, I decided to sort of expand the workshops. So through Youth Council, the US Embassy, I applied for a bigger grant that I needed. And then we designed build and fly workshops. And they took place in Pristina. Yeah. So this is the build and fly workshops. So as I mentioned, we designed it in 3 different sessions. The first session contained an introduction to RC where we explained each component, what goes inside an airplane, how can you make one object fly, and the basic rules of aerodynamics and physics. The second part of the session was learning how to fly a plane or a flying object using flight simulators, as you can see in this picture here. During the day, they just learned how the plane behaves with the radio controller that they had in their hands. And the final part was building the planes. Throughout that workshop, we built 3 airplanes, but we could take only one outside to fly because we did not have much time to finish the 3 of them, since the US ambassador came to visit and he really wanted to go outside and fly. So we finished that one, and in the first try that we did, it flew for more than 2 minutes by one of the participants who was in the workshops. And we were so proud because we could see that in only 2 days, we could teach them a whole new hobby, not all of them had background in engineering or in technology, but they all just caught what we were trying to get to them. Now I want to invite Dren to show you more about the things, a way how you can, if you're interested in the hobby, how you can be part of it, and he'll talk more about that.
Thank you.
Thank you.
I'm guessing you can hear me. Okay? Yeah. Okay. Oh, sorry. So just a quick technical introduction to the hobby, I would say. If anyone's interested in building an RC plane, RC planes nowadays are really cheap to build. Mainly because these components have gotten so cheap online, especially from Chinese suppliers. You can buy them really cheaply. For example, all you need to build an airplane is this radio. This is the radio on the left. This is the most expensive component, but this is reusable. So if you're planning to stay in this hobby, you can use it for your other projects. You can also you have to get those receivers. Usually you get a receiver for with the radio, but you have to get a receiver for each airplane that you build. Then these are the components that will get mounted to the airplane, for example. You have the motor and speed controller, and this is basically what powers the airplane, right? Because this connects to the receiver, and the radio gives it commands, and it powers the airplane. Also, you have these servos here to like move the airplane left and right, stuff like that. Okay, so besides this, you have to buy some insulation foam. Our plane was built using insulation foam. You can buy it at any store which sells home improvement stuff. So that's really cheap. That's like two euros for a meter square or something. So this in total would be somewhere around 50 euros. Including the radio, which you would buy only once. Okay, so airplanes, as Flutura mentioned, are really fun, and flying them is a good way to like get into the hobby, and really, it's a relaxing feeling, and sometimes not so much when the wind is blowing too much. But if you want to go to the next level, if you want to have an experience with much more adrenaline, then you have to move to the next level, which is quadcopters. And of course, I'm sure that most of you have seen these quadcopters which are commercially sold, like the DJI Phantom and things like that. These are made to be mostly controlled by the device itself. So basically, all you have to do is tell it, go a little bit there, or come a little bit closer, go a bit higher, or stuff like that. This is different from that. This is called a mini quad. So it's smaller than that, but don't let the size fool you. This is packed with power. At full throttle, it delivers more than 1 kilowatt. That's crazy. And for its weight, it's really crazy. So these things can reach, not this one, this is the one we built it for ourselves, and it's actually here right now. This one maybe can do 60, 70 kilometers per hour, but there's things online that reach 100 miles per hour. That's like 160 kilometers per hour. And why this does give you so much adrenaline is because you are in total control of it. It does not provide any help for you, like you're going too close to the ground, I'm just going to go up. No. If you're going too close to the ground, you're either going to crash, or if you're too good at it, you're going to move away from that situation. So this is the quad, and we built it ourselves. The body is all made of carbon fiber, and that's understandable because we're going to crash this a lot, like a lot. So in order to build one of those, there's a lot more components than building an RC plane. So first, you have to have this body. You can't make it out of styrofoam like the airplane, because it has to be durable. Then you have this receiver that we had previously. Usually we strip it out of the plastic and stuff like that because we need to make it so lightweight and so aerodynamic. We have to put all this stuff inside a really confined space. And we have, of course, it's a quadcopter. We have 4 motors. And these motors are generally much more powerful than the motors that we use on planes. Then we have this power distribution board and these speed controllers that get linked to the motor. But the most important thing in this device is this piece here. It's called the flight controller. This is, when I said earlier, it's all up to you, it's not really all up to you. This thing here does a lot of things. It has a small computer inside, but it's really powerful. It can do in the order of 200 million operations per second. And it has gyroscope, so it tries to compensate for like pockets in the air which would disbalance your movement and stuff like that. But what's the most important thing is that we do not fly these devices line of sight. What is line of sight? Is what we flew the TARDIS. So we're looking at the sky and just moving it left and right and stuff like that. We fly FPV. FPV stands for first-person view. So what we do is we have these goggles, it's like VR goggles, that we put them on our head. And this quadcopter has this camera here, which is linked to this transmitter here. And it transmits analog signals because we want so little latency. So our really small actions to the controller, we would notice them in time and we would compensate for that. And that is the most important thing. So we all fly these through FPV. Okay, oops. So using these components, we built this one. This was the first one. It was not as good as this one, the one that we have here, or the one that you saw in the picture. It was really heavy. It didn't perform that well, but it was a start, right? So the good thing about this is that once you have some components, you can buy better components online and reuse the ones that you had previously. So you don't have to spend a lot of money each time you want to build another one. Okay, so the thing about this hobby, especially flying quadcopters, is that people think that you buy it, you fly it, and that's it. You're just going to go outside and fly it. No, like 20% of the time is going to be flying, 80% of the time is going to be repairing. So we have this saying that we tune it, we put it in our computer, we tune it, we fly it, 15 minutes later we crash it, we come back inside, repair it, and just go outside and repeat all this cycle again. So every time we go outside, we notice something, we see that this device is not behaving really well for our needs, for personal needs. And what's important is that everyone has their own quadcopter, because the more you use your own and don't use other people's quadcopters, the more you have a feeling, that grip that you have with the device. So since you're using it through that VR thing, the FPV, you're feeling that you're inside it. So it's really important to tune it for your own needs, for your own reaction speed and all sorts of stuff. So this was a few days back. I was removing the motors, or replacing the motors with some new ones. Okay, so these are the FPV. This is the FPV set. And you have here the goggles. I have some goggles here with me today. These are just like normal VR goggles, except for the fact that they're not stereoscopic. I'll come to that in a bit. And basically, these have a receiver, and usually the quadcopter or the airplane has a transmitter inside, linked to a camera, and it will stream analog video and sometimes audio. Sometimes people want to hear it as well to these goggles. So this is the camera. This is the receiver, the transmitter. Sorry, it transmits 200 milliwatts at 5.8 gigahertz. Sorry, this is a combo. It's a camera and a transmitter. It's low power, but it's really lightweight, so you can put it in your micro quad or something like that. And this is the receiver. We had it with us today, hoping to connect it to the projector, but we weren't that lucky. This is a DVR. Basically, we can look at it, record the session, check it later. How did we perform today? What can we improve tomorrow? Like sometimes we can stretch a GoPro camera into the quadcopter, but that makes it really heavy, and we usually want it so lightweight to make it really fast and maneuverable. Okay, so this is our friend Etrit flying. Of course, this can't be a footage from DJI Phantom, for example, because the Phantom doesn't allow you to do tricks like these. You can roll it, you can flip it, you can do stuff like these. And at this stage, we're much better than this. We can do better tricks. We can fly even lower, even faster. But this was an older video, and somehow we lost all the footage that we had previously. So we're stuck with this. So the idea is that you tune the quadcopter for yourself. And you keep tuning it, and you keep pushing yourself to the limit. So, because what is going to happen if you crash? You're not going to die, unlike crashing with the car. You're just going to spend some time repairing it. Of course, it's painful to crash because you're going to waste a lot of time repairing it, but you're going to be fine unless you crush it into yourself. So we have this cycle. So we tune it, we repair it, we go outside, and we fly. We fly, usually during the summer, we fly a lot, but during the winter, it's not so good because it's not waterproof yet. Okay, so I'm guessing that's it. Thank you.